النهارده ان شاء الله هنكمل اخر جزء في الباكس، وهحب اناقش معاكم البروجكت الاخير اللي هو له علاقه بالباكس اللي انا رفعته على البلاك بورد، بحيث برضو ان كان في بعض الناس عندهم اسئله، فاحب ان انا اوضح بعض النقط اللي انا عاوزها منكم في البروجكت دوت. فبالنسبه للجزء الاخير بنتكلم بقى على ان بعض الاحيان بيبقى في عندنا احتياج. طبعا احنا بنتكلم على الباك سيستم ان هو كله ديجيتال، وبنتكلم على المودرن imaging equipment كلها digital. Oh, I'm sorry, I have to speak in English. I'm really sorry. Okay, so basically you're going to start with the last part of PACS, which is related to film digitizers. We expect, because PACS is digital, we expect basically that all the data we have should be in a digital form. Okay, and usually all the modern imaging equipment are all digital. So basically, it's very difficult to imagine a situation where we have a film and we probably don't think that it might not happen. But actually, imagine that you have a certain hospital, and this hospital receives a patient who is coming from a rural area, from a different area. And basically, he brings his his health record actually as films and reports and things of that sort. So basically what you'd like to do is basically open an EHR record on your hospital electronic patient record, and basically add all the images from these films to the patient record there, basically. Okay, so basically you have to be able to convert the digital, the films, the analog films, basically into a digital form, into so that you can store it on the PACS archive and access it from any one of the reading workstations in the hospital. So basically, usually for hospitals that have all digital imaging equipment and they have PACS, they usually still have a film digitizer just in case they need to convert a film into a digital film. So film digitizers are very much like the scanners that we are very much accustomed to, but the very different thing about film digitizer is that you have to have the light from the other side. So for a regular scanner, you usually have a light and you have a sensor here, basically, okay? So basically, and you scan your document like this, and basically, this is how it works, basically. You basically shine light and basically detect the parts of the document and basically digitize it this way. For the film digitizers, you have to have it the opposite way. Basically, you have to have the light from here, and you have to have the sensor on the other side, because basically the film by itself, it doesn't have, if you don't shine the light from the other side, you're not going to be able to see anything on the film. Okay, just imagine that you have an X-ray film. If you have an old X-ray film, you can look at it. If you just put it on the table without any light from the other side, basically you're not going to be able to see anything. Okay, so you have to have light from the other side. This light can be in two forms. You might use laser, or you just use a regular fluorescent bulb like the ones that you use basically in regular scanners. Okay, so basically this can be actually LED light also as well. Okay, but there is difference between these kinds of lighting and the lasers. Lasers are, we're talking about a very narrow beam here, and this beam actually you scan it through the radiograph so that you can get a very high resolution version of the radiograph. Okay, for the fluorescent light, because definitely this light is not as sharp, and usually the number of sensors here in the charge coupled devices or the CMOS sensor or whatever, these are very much similar to what you would use in a digital camera. The resolution of these is never as sharp as a laser scanner. So basically laser film scanners are much higher resolution than the ones that use CMOS or CCD or these kinds of sensors, basically. Okay, because here the light is diffractive, basically. Here you have a very narrow beam, and basically this narrow beam is detected, and basically you scan through the radiograph with this beam, so basically you can get as high of a resolution as you want. Okay, so this is much higher resolution. But the point is here it's much faster, and the quality is usually very good. I personally have one of these scanners, and actually used it to convert some of the some films into digital format, and it's really good. The resolution is really okay. But sometimes if you're talking about, if you're scanning, for example, here something like a mammogram or something like that, usually you'd like to have a laser scanner because the resolution for mammography in particular is much higher. The requirements there is much higher than what you would have for another regular film, okay, or another regular application like chest X-ray or whatever. Okay, so basically all you have to have here is basically a lamp from one side and a sensor from the other side, and you put the film and basically you detect the different areas, and this actually moves so that you can actually, both of them actually move together like a regular scanner, like a regular copying machine, by the way. It's very much similar, but actually they are on opposite sides. And basically you you read this CCD or CMOS sensor, and basically you put it in a digital form, digital image form. For the lasers, you have to have a little bit more processing, because basically here you're detecting a very fine beam of laser. So basically you have to have something like a scintillation detector, and this is actually is done usually like a photomultiplier tube, basically, which makes it really sensitive. So the dynamic range here is also very high. So basically the resolution here is very high, and the quantization also is very high. The difference between these two is that the resolution, for example, I say that I'm going to take an image that is 5K by 5K. This is the resolution. The quantization, I say that I have, for example, 32 bits per pixel. So each one of the pixels in the image, I can have it in 32 bits of information, basically. So basically, it's very deep. So basically, you have to have, or basically, the dynamic range here is very high. So you can have, and usually this is not required. Usually a 16-bit should be enough, but actually you can go as high as you want. But usually, because of the ability to do that, the ability of detecting very low echoes, very low light from here, you have the ability to detect very slight or very subtle variations in the intensity. Okay, so basically you have a very high dynamic range coming in from the laser beam here. So if you want to put it in a 16-bit image, for example, you have to have like some kind of a dynamic range compression. Dynamic range compression basically takes a very high dynamic range, like 100 decibels, for example, and compresses it into something a little bit less. Okay, and it does that in a way that doesn't basically lose the low echoes. Basically, what it does, it saturates the high echoes first, and then basically magnifies the low echoes. So basically, this is very common, and this is used in other applications like in ultrasound imaging, and it's actually very useful to obtain a very high quality image without losing the parts of the image that have very low echoes. For example, if you look at this image here, most of the interesting areas are black here. Okay, so basically, if you lose dynamic range, basically you're gonna see all this area as black. Okay, you don't want to do that. If you want to compress the dynamic range, you basically, instead of having something that goes like this, linear like this, basically you make it, basically, if you take the logarithm of something that looks like this, what you're going to do is, instead of going, for example, here 1,000, 2,000, and so on, basically in the logarithmic scale, basically, what you're going to do is you're going to have 1, 10, 100, 1,000, 10,000, and basically the distance here between, for example, 1,000 and 10,000 is exactly the same as the distance between 1 and 10. So basically you expand the echoes here, you expand the intensities, the low intensities, and compress the high intensity, but you still have differences between the different intensities. So basically, if an echo, if a place in the image, for example, here is higher than here, it's going to be the same. This is going to be also the same way in the logarithmic compressed image. And this is very good because basically it keeps the contrast in the image, but actually because of the high intensity parts of the image don't have much contrast. The contrast is mostly near the parts with very low echoes or very low intensity. Then basically the difference here doesn't really matter. Basically, the part here matters more. Okay, so here you have a logarithmic amplifier, and then after that, after you compress the dynamic range, you convert it into digital format and put it in a digital image. So basically, you don't really do these things. Usually, the scanner that you buy actually does these kinds of things. But actually, you have to choose between these two types. You have to choose either a laser or a charge-coupled device, or another technology like CMOS sensor technology. And this is actually much higher resolution, but it's slower, definitely, because you have to move the sensor and the laser all over the image like a zigzag pattern like this. And basically, it's higher resolution and it's higher dynamic range. If you want to have a very high reproduction of the original film, basically this is the way to go. If you want to have a fast way of getting the image, then this is actually the way to go. This is much cheaper. This is much more expensive. Okay. So basically, this is usually used for teleradiology, for storing film studies from outside to PACS, or for film duplication. Okay. For example, if you have a film that you want to duplicate, what you have to do is just scan it and then print this into another film. Okay, this is the only way you can do this. You cannot take a film and basically go to a photocopier and basically make a copy there. You have to actually make a digital scan of it first, and then use this scan to print it into a film printer that we're going to talk about in the next slide. So it's used for teleradiology because sometimes you actually have some imaging modalities might not be digital. If you still have legacy equipment in your department, if you're in the radiology department of your hospital, you still need the images from these systems to be read by doctors using PACS, okay? Or basically you want to send these images to a consultant using teleradiology, okay? So basically you need to scan the output from these legacy systems or the old systems you have, and basically put it in PACS and make it accessible for reading stations and for teleradiology. And also, as I told you before, you actually can store film studies from outside. So for example, if your hospital doesn't have a certain type of imaging modalities, for example, if you don't have nuclear medicine, for example, okay, and basically you send your patients to another center or another hospital to do such imaging there, okay? And unfortunately, this other place doesn't have PACS, doesn't have basically doesn't output the studies that you do there into a digital form. They actually provide films to the patient, but you still want to have these films added to the patient record in your hospital, or it can also be sent to the referring radiologist or referring doctor, okay, along with the report. So basically you want to have it in a digital form so that you make things easier to exchange such information. So basically, film digitizers, even though at the beginning of the introduction of PACS, they were very common. Usually you would have more than one in each hospital because actually most of the equipment were not digital. Now you have less, but you still have to have at least one, okay, because it's important. This is actually one of the regular brands, one of the common, commercial systems that do that. So basically, put the film here. It basically scans the film and basically gives you an output image on the system. So basically, this is connected to the one of the PACS workstations. Usually, it's connected to something. Usually, this is actually placed in the file room. We said before that we have a workstation in the file room. And this workstation is used to do such scanning. Basically, you don't have to have a medical grade display to do that, because basically you scan the image and just make sure that it came out right, okay? But you're not the person who's going to read it, okay? So basically, just make sure that it's okay, and then save it to the PACS archive. The doctors, the radiologists can then, basically call it from there or search for it and basically add it to his work list and basically writes the report as we said before about the retrieving the image from the PACS archive. Okay, so basic film digitizers are very common. Sometimes you call the workstation where you have a film digitizer and a computer. This is a regular computer, as you see, and this is a regular monitor. Sometimes you call it a PACS gateway, meaning that you actually, if you have an analog film, basically this is a gateway to PACS. You take this or use this gateway to convert your film into a digital form and add it to your PACS system. Film printers are not as common these days, but maybe 15, 20 years ago, they were very common. They were the only way you can get reports or basically get the images from the such modalities like CT or MRI to the referring doctor. So basically what the radiologist would do is to sit down and write the report and then select the images, and you can divide the film the way you want. Basically you can do whatever you want. You can make some of them larger, some smaller, and you can actually if you have some images with annotation, you can choose them and basically print whatever you want there and attach that that image or that film to the report. So basically, the patient would take that film in addition to a hard copy of the report and go to the referring physician in order for him to see the output of the radiological study he ordered for the patient. Okay, so basically you have something that looks like this. You have two forms of film printers. Okay, they call them usually imagers. Okay, so imagers is not like imaging modality. Imager is usually, as a word or the terminology, it's meant for the film printers. Okay, so basically you can retrieve images from the workstation and print them on a film using one of two technologies. Usually you either use a wet imager or a dry imager. Wet imager looks like this. This is a wet type of imagers, and this is a dry type of imagers. Let's start with the more common and the simplest to use, which is a dry imager. Dry imager is like a printer, like a regular printer, that whatever printer you used before. Like instead of just printing on paper, you print on films. That's it. Okay. You don't have to have chemicals. You don't have to have any, for example, connections to drain and connection to water or things like that. It's just basically a device like this, and you just plug it in and basically connect it to the network, and that's it. Okay, and the type of films here is like thermal. Some of them are thermal, but usually you don't really need any kind of chemicals to basically process this film. Here it's a little bit different. So basically in the wet imager, it's like you send the image here and basically it exposes a regular film to this image and basically processes the film just like the regular processing that would happen in a regular film processor. Okay, so basically it has to process the film so that you can get it out and basically it's not just passing the film through chemicals, it's also basically it has to dry a film before it comes out. So basically here the connection or the connections that you have to use here includes electricity, includes water connection, includes a drain connection, includes that you have to actually fill out some chemicals. It's very complicated here. And another problem for the wet imagers, because you're using chemicals that are very environmentally unfriendly. Basically, you cannot just take the output from here into, or take the drain from here into the regular pipes of the drain. Because first of all, some of the chemicals that you use here are corrosive. So basically, if you use them in the regular pipes that you use in the hospital, it might corrode them and make problems. And the other thing that basically they are polluting. Basically, if you cannot really throw them with the regular drainage that you have in the hospital. So basically, you have to process them before you actually get rid of them. So basically, it's much more complicated to have a wet imager than to have a dry imager. So for the wet imager, you use chemicals to process the film, and basically you expose the film using lasers. So basically, this is much higher resolution and much higher dynamic range. This is actually, you get a very high quality image there with the wet imagers. The dry imagers are very much like the regular printer that you have, okay? And basically use heat here. So basically use some kind of a film that actually responds to heat. And this heat actually processes the latent image, basically the exposure that you made on the film, okay? And use heat to etch it into silver emulsion, and basically use laser to do that. Okay, so basically the resolution here might not be as high as here, but actually it's very good. But there are other problems associated with dry imagers. I'm going to talk about them in a second. But usually this is much simpler because all you have to do is just a regular printer. Basically, you just connect it to the electricity and basically connect it to the network, and you got your printer working. Okay, here it's much more complicated for wet imagers. So basically, wet imagers must be placed in a well-ventilated area because you have here chemicals, and usually they are used in a hot, condition, basically. So you might have fumes, and these fumes can be actually very toxic. So you cannot have it in a closed area. So you have to have it in a well-ventilated area. And usually you have to design the ventilation in the area so that you make sure that the fumes that come out of here do not accumulate in the room. So basically this is a bit complicated. And you have to have proper drainage. You have to have proper plumbing so that the corrosive chemicals that you have here doesn't basically corrode the regular plumbing that you have in the hospital. And basically it usually uses much more space than dry imagers. So basically you have space problem as well. So you have a design problem, room design problem. You have a lot more concerns with the design of, or basically a need to have drainage and special kind of drainage and special kind of piping in order for you to do that. And also the processing that happens to the drainage that comes out of wet imagers, in addition to being much larger than the dry imager. Dry imagers can basically place on a table. So basically it's a little bit easier to handle and easier to work with inside a limited space. Okay, so basically you add to that you have a cost of chemicals. You have to basically, these chemicals actually, they are not you buy them once. You basically have to replace them every now and then. And the quality of the output of wet imagers changes with time because of the chemicals. You're using the chemicals, and as you use them, they get basically the quality of these chemicals becomes a little bit lower with time. So basically you get lower quality images with time. So until you change them, and you have to change them frequently, you have to design the way of disposal of such chemicals. You cannot just throw them in the sink and that's it. You cannot do that. You cannot just throw them in the backyard of the hospital. You cannot do that. This is really a problem from the environment point of view. Maintenance actually is, as long as you have here, as you see, you have chemicals, you have pipings, drainage, you have fumes coming out that you have to find a way to basically dissipate outside of the room. You basically have a lot of things to take care of for the maintenance of such equipment. So basically you have a lot of things to check for and a lot of things to worry about if you use a wet imager. Okay, so basically all these things that we talked about makes this kind of imager less popular choice than dry imagers. Okay, they are still very high resolution, and basically some places would prefer to have such high resolution basically rather than the convenience of the dry imagers. Okay, we're going to talk about the problems of dry imagers. Basically, the quality of dry imagers is slightly worse. So this is definitely a concern. Okay, and the film quality tends to degrade over time. Just imagine that if you have one of the receipts from Jarir, for example, if you buy a computer from Jarir, for example, they actually tell you every time you do that, every time you buy something big like a computer or something like that that has a warranty, they tell you please take a picture of your receipt and keep it with the receipt, so that because of the receipt is actually generated from the cash machine, which actually generates it using a heat process. And the problem is that the receipt actually fades with time. So basically, if you wait for a year or something like that, it's going to be very difficult to read the receipt itself. So basically, this is exactly the same because the heat process used is very similar. So basically, the quality tends to degrade over time. So if you have a certain image or a certain film that has a particular quality that came out in a very high quality after printing or after you got it out of the dry printer, if you leave it for some time and you want to look at it again, you're not going to find the same quality, which is a problem. In addition to its sensitivity to heat and humidity than the conventional film. So basically, if you store them in an area where, if you, for example, in Saudi Arabia, and you store such films in a room that is not air conditioned, basically you're gonna come and find this film almost destroyed. Basically, you're gonna almost lose it within a year or something like that, okay? Because of the heat and the humidity, basically. So they are much more sensitive. So if you expose them to heat or humidity, the quality, actually, the details of the image might actually start to deteriorate very quickly. And this is actually, this doesn't happen with the conventional film, okay? So basically, these are drawbacks, but the major advantage you have is that you require only an outlet and a network connection. So it's much easier to use. If you add to that usually you need such films if you want to, for example, give the referring doctor, if you have a referring doctor from outside the hospital who doesn't have access to your PACS system, okay, and basically you want to return the report with images that he can look at, basically, then it's fine, because basically he's going to look at it and he's not going to go look at it again. If he needs to look at it again, he probably will ask the hospital to print another copy. So basically, this is made for short-term usage here, okay, for the dry imager. So basically, if you use it for short-term, then you don't have a problem. If you're planning to take this film and put it in a file, in a cabinet or something like that, or in a file room or whatever, or if you have a hard copy file, patient files or something like that, this is not a good idea. Regular films are much better. So basically, you use it as a backup in case the PACS is down. So basically, if you want to refer, or basically if you want to send the report to the doctor, but the PACS is not working, for example, and the doctor needs to have that information very quickly, then you probably print it from the imaging modality, because basically this can be actually connected to the imaging modality, and usually this is connected to the network, and the network is basically you have all the imaging modalities on the network, you have the PACS system on the network, you have the archive on the network. So you can, from the imaging modality, you can access the printer and you can print the film that you want. Okay, so basically you get a quick copy of the imaging study that the patient did, and you send it to the doctor so that he can make the decision about the treatment or whatever the diagnosis of the patient, so that you don't get delayed, or basically if the condition is critical, you don't cause the patient any problems. Okay. And usually also you can use it if your case is referred to by an outside physician, because sometimes the outside physicians, definitely the outside physician, don't have access to your PACS system. So basically, sometimes it's better to assume that that doctor doesn't have a computer, because not all doctors have computers. Usually doctors now have more computers, but actually some physicians don't have computers. So if you go to an old-fashioned doctor who doesn't have a computer, basically he's not going to be able to read a CD, for example. The next that I'm going to talk about is that you can get a copy from the data set on a CD, and you can basically send it to the doctor on a CD rather than on a film. But actually, if the doctor doesn't have a computer, then it's going to be a problem. Okay, so basically you print a film so that the outside physician who actually ordered the study, the imaging study, can actually get the results very quickly and in a format that he can read. You have any questions? The last thing, and this is actually very common these days, basically, usually if you go to a hospital, if you know someone who went to a hospital to do some kind of an imaging study like MRI or a CT, something like that, you usually get a CD, okay? You get a CD with the study there. And this CD actually has a what you would call an imaging software that allows the user, if you just have the CD, you can open the images from the CD itself. You don't have to have any imaging software on your computer. It doesn't require you to have any particular kind of software on your computer in order for you to be able to see the study. So basically, if the referring doctor has a computer, then you can just get the CD and basically give it to the doctor so that he can basically look at all the images if you want to. Okay, so basically this is a good idea because first of all, the doctor will have all the images. The quality of the images will be almost the original quality because you have it in a digital format. You didn't print it out and then you look at it after that. And usually it's cheaper as well because film printing actually is basically one of the costly parts of PACS. Okay, because films are very expensive usually, okay? It's definitely more expensive than a CD or a DVD, definitely, okay? So basically laser film in particular is expensive than, and most hospital expensive usually than the ones used for dry imagers, okay? And most hospitals try to reduce the amount of printing done. So basically it's like, very much like what we actually try to do with paper now, okay? You're trying to, instead of printing everything, you basically try to read everything on your computer so that you don't have to print it. Because actually sometimes you feel guilty about the quantity of paper you use, and basically this is definitely not good for the environment. Okay, so basically it's expensive and basically it's also environmentally unfriendly, and at the same time basically sometimes you really don't have to print the film. Okay, the alternative here is to have basically burn the images on optical discs. Optical disc means CD or DVD. Sometimes actually you can put it on a flash memory also as well. Okay, things are moving now towards the flash memories because CDs and DVDs are not as reliable these days. Okay, and actually, if you look at the newer computers, very few newer computers have CD or DVD drives now. Okay, usually the newer laptops, they don't have even a DVD reader or a DVD drive anymore. So basically, people actually are moving also to flash because it became cheaper, and you can put whatever you want there, and basically you can reuse it afterwards. Okay, so basically, but if you still want to have the CD and DVD, basically PACS vendors offer the ability to burn images to CD and or DVD for purpose of sharing images outside of PACS. And usually you have a DICOM reader. Basically, DICOM is the format of the image. Okay, this is the image format. We're going to talk about it in details in the last part of this course. So basically, that's why you need to have a special software in order for you to be able to read it.
Doctor,
if it's JPEG, yes.
Doctor, DICOM is a standard, right?
Yes, but it's a standard for image formats. It's a digital image communication.
Because you are saying it's a kind of format.
Yes, it is a format, but it's format that is governed by a standard.
So it's a kind of a program.
It's an image format. Basically, you see images that are, for example, .dcm. Okay,
like
DCM,
JPG in the computers.
Yes, but it has a lot more features. A lot more features. Basically, inside this DICOM image, you don't only see the image itself. It's first of all, it's compressed there. Second thing, it has all the information about the patient, all the information about the imaging modality that you use, all the parameters of the imaging modalities that were used to acquire such image, the position of the patient while taking these images, all information you need to know exactly what happened in that imaging study. Okay, you can actually include in one file, you can include a 3D volume. It's much more versatile. It has a lot of things. That's why basically it's definitely an image format, but it's more than an image format. It's definitely it's governed by a whole standard because it has a lot of parts and a lot of utilities. Okay, that's why if you put the images in the standard DICOM format, you're not likely to find this format readable in a regular image viewer on your PC or Mac. So basically, you have a DICOM viewer so that you can allow people, if you have the CD, it has a DICOM viewer on the same CD so that you can actually use it to read the images from there directly. Okay, and sometimes it allows you to do some basic enhancements, some basic manipulations that we talked about before in the reading workstation. It's not definitely the full version of such utilities, but actually it can have some basic enhancement and measurement so that the doctor who's going to get that CD can actually do some kind of manipulation or some kind of measurements or calculations on the images that are included on the CD. Okay? Do you still have any questions?
No, thanks.
Okay, so basically, most imaging systems will offer the ability to save on a CD or a DVD. Okay, sometimes the imaging modalities don't have a drive like this. So basically, you have a DVD burner like this attached to the network. So basically, you can access it from any imaging modality. So that, or basic from the reading workstation, so that you finish the report, and you can actually put the report on the CD, and also you put the images that you want, and you put the reader, you put everything on the DVD, and basically label it as well. You can actually put the label as well with the patient name and everything, so that the patient can get his image without, or his images without confusion with other CDs for other patients. Usually this is one way of doing things. Things now are moving to allow the doctors from outside the hospital to have some kind of access through teleradiology. We're going to talk about this in the next chapter, inshallah, next topic about HIS, which is related to actually in the topic that we're going to discuss maybe right before the last one, which is about teleradiology. So basically, you can have a portal where you can actually allow certain physicians from outside to access your images from your PACS system. And basically, things are moving in that direction because exchanging the images in either film version or a CD or whatever, this is not very convenient. Whenever you have a hard copy, this hard copy might get lost, might get distorted, might get basically, if you have a CD or a DVD, it might get exposed to heat or whatever, and basically it doesn't work anymore. You might have problems in the format, or you have a lot of things that you may worry about there. So basically, people are now starting to have access through web portals. You have a certain web page, and basically you have certain access. You can give the doctor from outside a certain access credentials so that he can access certain patients from outside. So basically, people are now moving to have the connectivity through the internet rather than printing films or burning DVDs or CDs. Okay, so basically, if you do that, you're basically saving all the money that you need, all the costs that you need to do that, and at the same time, you have much more reliable way of communicating the images. So this is basically the last part of the PACS part of this course. I added a few, added basically a new project and a bonus project. What I'm going to do now is I'm going to go over the new project and the bonus project so that you understand exactly what I mean by the different parts of this assignment, okay? Probably after that, I think we don't have much time. So basically, I'll prefer to start a new topic next time, inshallah. So basically, now I'm going to close this presentation and open the other one. Open the assignment. Okay, you can see here the project. Can you see me?
Yes.
Okay.
Yes.
So basically, in this project, actually, the goal is, as is written here, can you see the cursor? Can you see the cursor?
Yes, you can see it.
Yes.
Okay, great. So basically, a study of the specifications of medical grade monitors for use in PACS workstations. The thing I told you about in the PACS workstations is that the most expensive part of the PACS systems usually is the medical grade monitors. These are very expensive, and they are at the core of the function of PACS. Because basically, the core of the function of PACS is to allow the radiologist to, to read the images, read the radiographs in the best possible way. Okay, if you have a poor monitor for the radiologist, then he will not be able to read the images properly, and basically there will be mistakes in the report. Okay, we don't want to have that. So basically in this project, what you're going to do is to research the specifications used to define medical grade monitors that are used in the radiographer reading PACS workstation. Okay, I added a few resources. So basically you should start with the reading material that I provided to you, and basically continue to research the topic from other resources as needed to form a coherent report. Let me show you exactly what I mean by the resources. First of all, there is a standard here. Basically, ACR, AAPM, these are very well-known societies here. ACR is American College of Radiology. Okay, AAPM, this is basically association. I think it's physics and medicine, but I'm not sure of American. I think Association of Physics and Medicine, for physics and medicine, something like that. So basically, these are very well-known organizations, and basically they control the standards and they control basically how things are done in this area. So basically, this is a standard that is not just talking about the medical displays; they are talking about other things as well. Okay, so basically, it's talking about in general electronic practice of medical imaging. Electronic practice of medical imaging includes the display. This is a very important part, but it includes other things as well. So basically, to include things like how we're going to compress the images. If you want to make the image size a little bit smaller, how you can do that without sacrificing the quality. Things of that sort. But let's go a little bit to see what's written in there about the display. Okay. Basically, it's a very nice thing to have a standard like this so that you can, get the full information, and basically you can read only the part that you need, basically. Okay, it talks about such things that direct image capture, that scan the radiographs, graphic films. It talks about actually how the specifications of the scanners that we just do, the film digitizer that we talked about a few minutes ago. Okay. Compression, image compression. If you want to have, if you want to do image compression, definitely you have lossless compression or lossy compression. Which of these is acceptable, and what are the parameters? If you're going to use lossy compression, what are you going to do? Things of that sort. The important part you should look at is the display part here. Okay, so basically it's going to talk about the general requirements for display workstation, basically the workstation characteristics. Basically talks about here, for example, graphic bit depth. How many bits per pixels that you're going to have? The operating system of most workstation manages images with red, green, and basically talk about 8-bit or 256 values, basically. Okay, so basically it talks about exactly what you need for the bit number of bits here. Okay, it talks about the display technology. Display technology might have LED or OLED or whatever, things of that sort. The difference between these two, or the different technologies used. Okay, the graphic interface talks about, for example, the connector. Okay, you might have, for example, VGA is a connector, DVI is a connector, HDMI is a connector. So basically talks about which one is preferred, or basically explains the difference between these two things, or these kinds of technologies. Okay. How are you going to present the image? Basically, the size of the presentation of the image, how large the image should be, okay, how it should be displayed to the doctor. So basically, it's put there as well, okay. All these kinds of things you have to actually go through very quickly, and basically look at the ergonomic factors that are related to the comfort of the doctor, okay, so that you actually minimize, for example, eye fatigue, okay, so that you make the doctor more comfortable and can work longer hours without being fatigued. So basically, the actual display characteristics, if you're going to buy a display, a medical grade display, you have here the detailed specifications, and basically it defines something like the luminance response, which is related to the brightness and contrast of the grayscale medical images. And basically, it defines exactly the parameters that you should have for a good display. So these are the kinds of things that I'm going to ask you to basically summarize. Okay? So these are very important. Okay? So this is the first one. This standard actually is meant for general radiology. Mammography has a different, more detailed part about the image quality here. So basically, you might find some requirements in the display part here a little bit more demanding than the ones that you see actually in the general radiology part. Okay, so basically, if you go here to the digital mammographic image display, this is different. This is a higher quality image display than the regular radiology image display. So basically, I want you to see the difference between these two. This is actually a very nice paper. It's what's called IT reference guide for practicing radiologists. Basically, this is like a guide for radiologists who are not engineers like you, okay? To make the radiologists understand the technical terms and the technical specifications of things related to the topic that you talk about here. So here, the focus of this guide is displays, basically. So this is a very nice guide that would allow you to understand exactly the display technologies and the difference between them, and how to choose them, and how appropriate of such technologies are to different kinds of applications. So this is very nice resource if you want to read it. It even has the way the DVI connector looks like, things of that sort. So this is really nice. I'm not asking you in this report to read all of them. Basically, I have some questions. I gave you some resources, okay? What you need to do is basically try to answer these questions. If you, for example, read the first line of the first resource of these. So basically, if you go to one of these standards and read the first line, and you find the answer to all 4 questions, that's fine. You don't have to read anything. I'm not going to ask you whether you read everything or not. So if you're able to answer these questions in any way, okay, it's fine. So basically, these are suggested resources. In my opinion, they are valuable resources. Okay. If you don't think so, if you have more valuable resources, if you have a different opinion, that's fine. But just answer these questions. Okay. The first one is why medical grade monitors should be different from conventional digital monitors used for personal computers. Why do we need to go and buy a $10,000 monitor rather than just go to a local computer store or something like that and buy 1,000 riyals, 1,000 riyal monitor? Okay, what's the difference? Why should I buy this much money, or why should I pay this much money to a monitor just because it's labeled as medical grade? I need to understand what medical grade means. Okay, so this is the first one. Again, I'm not asking you to have a comprehensive answer, just have a good idea about why medical grade monitors are different from regular monitors. The second thing is, what are the main specifications of medical grade monitors? So now if you're going to have, I suggest in this part that you look at websites for vendors, for companies that are manufacturers of medical grade monitors. if you look at the brochure of one of these medical grade monitors, what do you expect to see there? What are the specifications that they put there? Okay. What are usually when you read this about this, when you have the difference between medical grade monitors and conventional monitors, you're probably going to find some parameters of the monitor that are very special for medical grade monitors, compared to the conventional ones. So these might be the specifications that are the essential specifications that should be there. Okay, so basically imagine yourself basically as a biomedical engineer in a hospital. You're asked to buy a medical grade monitor for the PACS workstation. What kind of specifications you have? How are you going to compare different medical grade monitors? Okay, so basically these are the kinds of things that I would like to see there. Are medical grade monitors used for mammography different from the other medical imaging applications? This is actually what we just talked about. You have a standard for general radiology, and you have another standard for digital mammography. So obviously, digital mammography has some other, basically some more requirements than the regular or general purpose radiology. So basically, just try to know exactly what these things are. Okay, why are they different? If they are, first of all, you have to answer if they are different, and if they are different, different in what? Okay. The last part is, can you give or provide practical examples of medical grade monitors in the market? Basically, if you look for the specifications here, if you actually look for vendors, you're probably going to answer these two questions together. So basically, here you just say that I found this medical grade monitor in this from this vendor, and it has these specifications. And maybe here you should just give two examples, minimum. Just two examples should be enough. Okay, two different medical grade monitors from two different vendors. Okay, I prefer basically, please don't, usually if you go to one vendor, you're going to have different models. So for example, you have monitor from a company that is called, for example, A51. Okay, and probably there would be another monitor A51B. Okay, these are not very different. Okay, I want to see different examples so that you can actually see how different companies compete in making different kinds of monitors and different kinds of specifications. And when you compare their specifications, you might actually understand a little bit better about how to choose one of them. Okay, so basically just here give two examples, and basically this should be enough. The outcome of your report is just like the previous report. You're going to have a very short report of 2 to 3 pages. I don't want to have, please minimize the copy and paste. Okay, I don't want you to copy and paste. I want you to answer these questions in your own words. Okay, short and sweet, as they say, basically. Just answer to the point. Okay, if you have a list of things, you can do that. That's fine. But actually, I don't want to have a very long report. 2 or 3 pages should be enough. Okay. I'm not saying that if you have more will be a problem or less it's going to be a problem. Basically, if you answer these questions properly, basically in one line, that's fine. Okay, but usually I would expect 2 to 3 pages should be a very good size for a report here, because actually going to have a list of references. Please don't always remember to have a list of references. Okay, if you have a certain answer you find somewhere, please refer or cite the place where you find this answer, okay? So that you can actually learn how to prepare scientific reports that are ethically correct, okay? And in order to make sure that you actually understand what you have there, basically you're going to have also a 5-minute presentation. The easiest way to do the 5-minute presentation is to record it on PowerPoint. Okay, some of you sent me, different ways of doing the presentation without PowerPoint. They are fine, it's fine. But I mean, a PowerPoint looks much more presentable, much easier to do, and basically you can generate the image file without any problems. The video file without any problems. Okay, so basically you have a video, and basically you have the grade for this project will be divided 50-50 between the report and the presentation, the video presentation. Okay, As you probably may have seen, I already graded two of your reports. So basically, I saw a lot more basically this weekend. I'm going to, inshallah, have the grades, have them all graded by tomorrow, inshallah, yani by the end of the day tomorrow. But actually, if you look at the video channel, the YouTube channel of the biomedical engineering program, you're gonna find these presentations already posted. So basically, you're not only basically whenever you present something, you learn it a little bit more, okay? And the point of uploading them to the YouTube channel is that you're benefiting other people. So basically, anybody who actually looks at your presentation or views your presentation, you're gonna get thawab, basically. You're gonna get basically ajr for basically making this information easy for other people to access. Okay, so the projects here also is individual work. You can definitely collaborate with your colleagues and you can read together, whatever, but you have to write your own report and prepare your own presentation, okay? I don't mind if you actually think about things together or basically learn together or whatever, but at the end, you're required to have an independent report. The suggested materials are provided to guide you. They are not required, you're not required to read them. Some people actually worry that the number of pages in such documents is really huge. As I showed you a few minutes ago, you don't have to read all of them. Basically, there is a section in each one of them that is basically relevant to what you need to do or what you need to answer in this project. If you read this part, it should be enough. If you want to read it from somewhere else, it's still okay. Okay, it's up to you. So basically, this is how you're going to submit it. And basically, it's the easiest way to submit is basically submit the report on Blackboard and submit the link as a comment with your submission, so that I can access the Google Drive or whatever, wherever you posted the or uploaded your presentation, or the video presentation, I can download it from there so that I can upload it to YouTube channel. So basically, you can submit everything through Blackboard, okay? It's allowed to use any available resources as long as credit is properly given. For example, if I know someone who works in a company that sells such equipment, okay? And basically, if I ask that person all these things and basically answered me, it's fine to just have these answers, but basically, please put him as reference, okay? The point is not to innovate. I'm not asking you to discover, okay, the specification. I want you to learn about the specification. So basically, do this the best way possible. But please, if you use any resource, just give credit to that resource, whether it's a person, whether it's a paper, whether it's a book, it's a website, it's a YouTube video, whatever, okay? Just put this credit everywhere, okay? Put it in the report and put it in the video, okay? And this is very important to have a list of references that contains all the resources that basically used in preparing your report. Basically, I'm trying to, through this project, actually to prepare you to do your thesis, because basically the thesis will have to be, you have to actually match all these things in your thesis. So basically from this course, actually try to be ready for what you're going to do in your thesis, inshallah. This is also 5% of your grade. And basically you have a maximum of 3 weeks. So basically, I think it's by the end of March, should be fine. Basically, you have at least 3 weeks, okay? Do you have any questions about this project? Okay. The other thing is the bonus assignment. This time, actually, I created an assignment rather than just having a column in the grade center for the assignment, so that you have a place where you can actually submit this assignment. Okay, so basically there's a software called ImageJ. I told you about it maybe last time. This is actually, it's open source software that is available from the NIH, the National Institutes of Health of the US. It's a very comprehensive software, and the very interesting part about it is that it's open source. You can actually download its source. It's written in Java, but actually it's very interesting to have. If you want to know how to do a certain processing there, you can actually look at the Java. You're probably going to understand. You can still understand how it's done there. Okay, and basically you can convert it to any language you want. If you want to convert it to MATLAB or any other thing, you can still do that. So basically it can display, edit, analyze, process, save, and print many image formats such as stacks. Stacks are basically, instead of having, for example, the DICOM image that I was telling you about, if you have a DICOM image that has a full volume, that has many images, okay? This is called a stack. Stack means a number of images that you're stacking them together to compose a volume, or a series of images, basically. It's the same meaning, okay? You can do whatever you want, okay? But basically, what I want you to do here is basically do the kinds of things that we talked about in the lecture. We talked about window and level. We talked about measurements of distance, angle, and area. We talked about image transformation, including rotation and flipping. We talked about image enhancement, including contrast enhancement, image denoising, creating 3D representation of data. You can actually do all these things and more, you know, through this software. There is a tutorial here that allows you to know exactly what you do. So basically here you have all these things here in the tutorials, and these tutorials are not just things to read. There are actually videos that show you how to do that. So if you want to know exactly the kind of software capabilities that you should expect on the reading workstation that the doctor usually uses for reading the image, manipulating the image in order for him to generate the report. Basically, this is a very good example to learn this, this software from this bonus assignment. As with all bonus assignments, basically, you have time until very much right before the final exam to finish it. Okay, so basically, if you submit this bonus assignment like the same day of the final exam, I will count it for you. Okay, so that's fine. You don't have to do it right away. Just focus on the required assignments like project 3, the PACS project first, and if you have time, please try to do that. Okay. Do you have any questions? Okay, so this is it. I'm not going to start a new topic in the remaining few minutes. So basically, you're going to stop here. Inshallah, next time we're going to start a new topic. I'm still actually kind of not sure exactly whether to start the networking part or the HIS and teleradiology part. Okay. Basically, the networking part is a little bit different. I feel that the actual part about medical informatics, like the PACS, like the EHR, are kind of dry because they are all theoretical. Basically, you're just reading material without doing anything yourself. Okay, cybersecurity is kind of practical, and basically you have some skills you can have. You basically it's more related to things that you can do and you can see. So basically, it was a little bit different. So networking is also the same. So I was thinking about having the network starting next time so that we have something a little bit different, and then we continue the rest of the course with the medical informatics part. But the thing I would like to discuss with you actually is we need to have a midterm soon, okay? So when do you suggest we have a midterm? I think we have a mid-term, or basically what they call it a spring break. We're going to have a week, basically at the end of next week, inshallah, we're going to have a week of vacation. Or basically, you're going to have a week of vacation. For us, we don't have a vacation. Would you like to have the midterm right after the vacation, or what do you think? So, for example, I'm talking about maybe if we talk about March, then we talk about, for example, March 14th, March 13th, for example, or 15th. So mid-March, would that be okay with you?
For me, okay, doctor.
because the other thing is that we are going to have it in class. The university regulations mandate that all the midterms and the finals must be in class. Okay, so would you be able to come and take the exam on one of the, one of the times that we have lecture, or would you like to have a separate day, or a day you determine, even Saturday, in order for us to have the exam in class? First of all, can you come on the 13th, for example, March 13th? Can you come to school and take the exam at school?
Yeah, for me, I can come if it's possible.
How about the rest of the?
Yes, but will it be?
Oh, okay. We have people from far away. Okay, Yambo is about maybe 300 kilometers, something like that, right? 300-400, right? So what do you suggest? What do you suggest? I'll tell you what. Let me check if we can have it as online exam. Then we actually, if you don't mind at the university, at the department, then we can actually have it as online, so that it's more convenient for everyone. But you have to remember that in the final exam must be in class. Okay, it cannot be online. Okay, the university will not allow that. Okay, so maybe the midterm, I will ask if it's possible or not. Okay, if it's possible, then basically we're going to do it online. Okay, if you want to go do it online, I usually, for the midterm, I usually have a 1 hour exam. Okay, 1 hour. So prepare the exam for 1 hour. But actually, I'm going to give you the rest of the time. So basically, if you start at maybe 6:40, you're going to have time until basically the next class. If you have a next class at 8, then basically you can basically take another 20 minutes, so that if you need to finish something or whatever, you're going to have 20 more minutes. If you want to have even more time, maybe we can decide to have the exam on the same day of the lecture. We're not going to have a lecture on the day of the exam, but we can start the exam at 9:30, for example. It's totally up to you. Okay, so basically you can go and take the exam after you finish all your classes, and basically at this time you can actually have more time. You can probably have, if you need more time, you can have more time. But I prefer if you just have the exam at the same time of the lecture, and I believe an hour and 20 minutes should be enough. I mean, 20 minutes is like 30% more time than the time that the exam is designed for, and it should be more than enough, inshallah. Okay, so basically what I'm going to do is I'm going to send you the suggested date and suggested format after I confirm with the university here, and basically all the regulation, all the guidelines for the exam by message, by one of the announcements and the course report and the Blackboard, so that you make sure that basically if somebody is not with us in this lecture, he actually gets informed of this. The other thing is that the exam itself, basically we have at least 3 lectures, 1 lecture this week and 2 lectures next week before the exam. I'm not sure we should have something basic. I'm going to stop the part that is included in the exam at the PACS. So the last part included in the exam is the PACS that we just finished today. Okay, so whatever we're going to study next time, next 3 lectures actually, so the rest of this week and next week will not be included in the midterm. I'm going to include this information. I'm going to include exactly the coverage of the material that we had in this course in the midterm in that message that I sent you. Okay, so please just focus, read carefully the message that I sent you, because you don't want to be studying things that are not included in the exam. the exam itself will be open book, open notes, but it's not open friend. Okay, it's not open colleague. You cannot gather in a place or basically have your friend on the phone and basically solve the exam together. Okay, you cannot do that. Okay, so basically I'm relying on your honesty and integrity, basically an ethical behavior in this exam if you're going to do it online. Okay, and basically hopefully inshallah we'll do it online. And basically if you do it online, please just be sure that basically you work on your own. Basically, if it's an in-class exam, then basically it is basically still it's an open book, open notes. Basically, you cannot talk to your friends, of course. Okay. So I'll confirm about that. How many people would be able to come? Is it just one person who cannot come?
I'm also from outside of Jeddah, doctor. I'm from Taif.
So 2 people cannot come? Okay, let me check. If we have a problem, then we might think about other solutions. Okay, I was thinking along the lines of having the people who can come. So basically, if you have 6 out of 8 that are able to come, then we actually take an in-class exam for these students, and the other ones will be actually taking the same exam but online. Okay, but actually it's not a good idea. Sometimes you know, basically things are not fair this way. The exam should be delivered to everybody the same way. So basically I prefer to have it either or online or all in class. So basically I'll check the online tomorrow inshallah and send you a message about the regulations or the guidelines of the exam inshallah. If you have any questions about the exam or otherwise, please feel free to contact me. Okay? Any questions?
So as a summarization, you doctor will check with the university if we can have it online. Otherwise, we're gonna have it Sunday, March 13th, right?
No, online. Basically, we can determine the date. The date is exactly the same, but it's gonna be online. Basically, that's it. Okay. If not, we're going to have to determine a date that is suitable for you. That you basically, if you live that far away, then you might not be able to come, you know, in any day. Basically, at least it's gonna be difficult to come at night. Okay. So basically, we're going to have to discuss a suitable date for in-class exam. Okay. If it's not possible to do it online. For the final exam, we have no control over it. Basically, the schedule for the online for the university, basically, I think they have specific times for each exam. So basically, we probably should stick with these because we don't want to have conflicts with other courses. Okay, so basically for the final, we don't have a problem. But if we need to have an in-class exam for the midterm, then probably next time, inshallah, next lecture, we're going to have to discuss a suitable time that fits all of you. Okay, I expect them to allow an online exam for the midterm, but let's just check, just to make sure we don't want to have any problems at the end of the course. Okay. Any questions? Okay, so inshallah, I'll see you next time. And in the meantime, you will receive an email message regarding what the midterm guidelines will be like, inshallah. Okay, thank you. Assalamu alaikum.